Hello all, welcome back. So in this today's class, we are going to see what is the difference between combinational logic circuit versus sequential logic circuit. So later on, we'll see what is the limitation of combinational logic circuit and what is the need for going the sequential logic circuit, right? So if you observe here, we have the differences between the combinational logic circuit versus the sequential logic circuits, right? So if you read this, so combinational logic circuit means output that depends only on the present input value. So what is the meaning of this one is, suppose for example you consider simple AND gate operation or whatever it may be on logic gate, right? So you will be having the input terminal AB, output is the Y, right? So here for example, if you want to get the sum output, what you have to do is we need to pass the input value, right? So what is the possibility? Suppose if you are giving the input value 1 1, what is the expected output value as per the AND gate logic? It is the 1, right? It means that this is the output value which is completely depends upon the input value, right? So if it is output depends completely only on the input value, such a kind of circuit where we used to call it as the combinational logic circuit, right? So now see that what is the second point is that memory element is absent, no clock signal is applied. So we will see what is the meaning of this one, right? So next we will see the what is the block diagram representation of the combinational logic circuit, right? So if we consider here something not gate operation, so how many inputs we have? One input as well as the one output we have, right? So it means that combinational logic circuit may have the single input, or in some cases if you have the half adder, full adder, some other logic circuit, we will be having the multiple inputs, right? It may be one input or multiple inputs values we will be having. Then it may be in case of logic gates you will be having the one output. In case of encoder, decoder, multiplexer, you might be having the different types of output, right? So we will be having the inputs, then based on the you will be getting the output value. So this is combinational logic circuit. So what is the definition of this? Where output completely depends upon the input value is called as the combinational logic circuit, right? So what are the example for the combinational logic circuits are, right? So half adder, adders, then so if we consider adders, we have the two types. One is half adder, full adder. Again we have the subtractor also will come under the combinational logic circuit, where subtractor also, if you want to get the difference and borrow, we should give the input values, right? So it means that if output is completely depends upon the input value, then it is called as the combinational logic circuit. So one of the examples are the subtractors, then we have the multiplexer, demultiplexers, and encoder and decoder will also come under the combinational logic circuits, right? Now what is the limitation of combinational logic circuit, we will see, right? Suppose for example, as we discussed earlier, so again if you want to get the one more time output as the 1, so if you observe here in the previous case we have passed the input, right? What is the input we have passed is the 1 1. So for that we got the output 1. Now what I'm going to do is, again my requirement is that I need to get the output as the 1, right? So again I need to get the output as the 1. So earlier we have already passed the value 1 1, so that we are getting the output value 1, right? So this task is completed. Now next time what is my requirement is that again I need to get the output 1. So it means that, so here you cannot able to call the previous output function. It means why we cannot able to call the previous output function means, right? Why we cannot able to call the previous output function means, because it won't remember anything, means it won't store any value. Whichever output is produced here as per the given input, it won't store any information. So it means that what is happening means it won't remember anything, means the next time if you want to get the output as the 1, right? So again we need to pass the input value as the 1 1, right? So if you didn't understand, for example suppose let is something like this, right? So now if you observe here, I have the internet connectivity here. So for that what I'm doing is I'm going to my Google, right? So just for example I want to play some particular song, right? So some particular song or particular program, whatever it may be, it is currently playing. For example, let it be, it is currently playing, right? So now what is my requirement is that, right? So it means that we are giving some input so that we are getting this output as the display as the output value. Now see that, for example, let us you consider I don't have the internet connection, right? So internet connection means, again if you don't have the internet connection means, again if you want to see the same videos on, you cannot able to get the information. The reason is that every time if you want to get the output, by default we need to pass the input value, right? It means that combinational logic circuit, it don't have the memory operation. Memory means it don't have the storage capability. If it does not have the storage capability, then you cannot able to recall any information, right? So it means that again if you want to get the output as the 1 1 means again we need to pass the input 1 1, so that only next time you will be getting the output as the 1. If you want to get the one more time output as the 1 means again we need to pass the input value 1 1, right? So instead of doing that like this, for example, suppose that this is my combinational logic circuit, it is producing the output 1. So by using some memory element, right, so let it be this is my memory element. So whatever the output is producing here, the output I am going to store here. Next time whenever it is required, we can call this output, so that we will be getting the same output value, right? So simple. What is the definition of the, right, sequential logic circuit means, the simplest definition of the sequential logic circuit means it is also combinational logic circuit. CLC means it is also combinational logic circuit. Additionally, we will be having the something called as the memory element operation. So memory element is nothing but the, we have the storage operation. So combinational logic circuit plus additional memory element is operation is what we called as the sequential circuit. The one more definition is that if output depends on the present input as well as the past output, then it is called as the sequential logic circuit. See, if output depends on the present input as well as the past output, then we can call it as the sequential logic circuit. What do you mean by this, right? Suppose for example, let us say I'm going to consider some AND logic gate, right? So this is my AND logic gate. What is the first time I'm giving? Let it be this at time period t1 I'm giving the input 1 1, so that I'm getting the output as the 1, right? So next time what I'm going to do is I'm going to pass the one more input value. Now at the time period t2, this is what we called as the present input value, this is what we called as the previous input value, right? This is we called as the past input, right? So 0 1 means what is the output value? 0. This is what we called as the present output value, this is what we called as the past output value, right? So generally what I do, so whatever the value it is generating, which is going to stored into the memory element, right? The previous output it is going to store the memory element, right? So if it is required, we can pass this information to input of the AND gate, right? It means that, so what is the definition of the sequential logic circuit means, where output depends upon the present input. Present input means what is the input that we are going to give currently, right? So this means this is the present input. What is the input that you are going to give currently? That is what we called as the present input. Then previously we have stored one value, right? Right, at the time period of t1, that is nothing but the past output value, right? So it means that if output depends upon the present input value as well as the first output is generated, right, that is what we called as the previous output value. So such kind of circuits are called as the sequential logic circuit. Now if you observe here memory element is present. So what is the meaning of memory element is present means, so here we have the storage capability. If you have the storage capability means, then it is called as the sequential logic circuit. If you don't have this, right, so storage capability, then it is called as the combinational logic circuit. That is the only simple difference. So now if you see this block diagram, as I explained earlier, so we may have the one input or multiple inputs, right? For example, if you consider the single input, CLC means combinational logic circuit, we will be getting the input value as well as we will be getting the output value. Now if you have the storage capability, right, so nothing but the memory element, so this we can call to the input. It means that whatever the value which we stored in the memory element, that we can call to the whenever we required. So along with this input, we can call this value to our combinational logic circuit, so that again we will be getting the one more output value. Now see that if you have the memory element, then it is called as the sequential logic circuit, right? Now what are the examples is, we have the flip-flops, counters, registers. So these are the some of the example for the sequential logic circuit, right? In the next classes we will see how to design flip-flops as well as how to design counters as well as how to design shift registers, everything, right? So simple point is that combinational means output completely depends upon the input, sequential means combinational logic circuit only, but extra we will be having the storage capability. The storage capability we are calling as the memory element operation. So whatever the output is currently generating, which we are storing into the memory element, so whenever it is required, that information we are calling along with the our present input value. This is nothing but the past output value, right? If you see that present input plus past output value is nothing but the sequential logic circuit, right? Thank you.